Okay, so welcome back. This is part 3 in our series where we help you put together an application that does 3D ray tracing using C++, and it also utilizes your GPUs to make it render much faster. So in parts 1 and part 2, we showed you how to put together this simple application that does ray tracing. And in part 2, we added a library to address one of the shortcomings of the original code, which was the original code did a nice ray traced image, but it merely sent it out as an image file to your hard drive. And that was from the ray tracing in one weekend code. And it saved it out as what's called a PPM file. And we looked at PPM files and what they are. And what we did in part 2 was we added a library called SDL that allows us to add a window and to make very simple change in the code that sends the image to a file, and instead it sends it to a window in your application. And here is the code. Here you can see it's fairly straightforward. So what I'm going to do is I'm going to hit Control F5 to run this, and this is what we've got so far with our ray tracing application. You can see it renders it now to a window, and up here we've got some information on what's going on. We're using our two NVIDIA GeForce GPUs on this machine, and the CUDA code that we showed in the previous videos is what's going to allow you to access the GPUs and run this ray tracing on those GPUs. And you can see we've got a 1280 by 720 image here with 10 samples per pixel and 8 by 8 blocks. And it took only about 2.5 seconds, okay? So it's very fast, and it's using the GPUs, and it's doing ray tracing with a fairly complex image. You can see here we've got glass, we've got what's called depth of field blur. So the stuff that's really close is blurred, and the stuff that's far away is blurred. And we've got a reflective surface, we got glass, we got shadows. So really kind of complex image. So it's got a lot, it's got different colored materials, and it's really fairly simple code. So in the previous video, we showed how to do this SDL window. And if you look real closely at this image, you might notice one slight problem with the image. And of course, it's upside down, all right? So in the previous video, we showed what's going on with the original code that saves it to a file, to a PPM, is it's basically starting from the bottom left and rendering the pixels, where we want it to start from the top left and render from top down. So instead of going into the depths of the code to find out what's going on, what we're going to do in this video is we're going to find a simple fix, basically one line of code with the SDL library that will allow us to fix this. Now what I'm going to do, I've got my image here, and all I'm going to do is I'm going to press one button on my keyboard and see what happens. There you go. And this is one of the features of SDL that we're going to look into. Basically, SDL is event driven, which is really, really important. It allows you to grab an event from your keyboard, your mouse, your joystick, or whatever, and allows you to take that event and do something when it sees that event. So we're going to set this up with very little code to recognize pressing a key on the keyboard and using a very simple modification to the SDL code that renders this, that allows you to flip it vertically, which is what we're going to do here, flipping it vertically, or you can flip it horizontally, you can rotate. So it's got a lot of functionality. It's going to give us the opportunity to get into SDL and find out some of the other features. The existing code with SDL, as you might recall, what we did is we did some event capturing, and that was when we click the X button on this window, the close button, it senses that event and ends the program. And you can see here it has ended the program, and since we ran it with Control F5, it's waiting for user input to end this console, and I press a button, and now we're all set. So what we're going to do is we're going to show a very simple modification to SDL to allow us to flip that image. So here we are in our application in our main.cu. Okay, this is the entry point. It's the CUDA version of a CPP file, and it has our main method. And you can see I've got our includes, I've got some documents, and here is the CUDA code of the functions doing the rendering. But we're going to go past that, and we're going to focus on this main entry point. And we're going to make a few minor changes in that. So I'm going to expand the main, and you can see here it starts out where we have this code that we added last time to generate the window and the renderer. And then we have the code where we printed out the CUDA GPU devices that we saw before. And then we come down here is where we actually send the RGB values for each pixel. And originally it used this line, stdc out, where it sent that to a file. And what we did is instead of sending it to a file, we commented that out and we used the QB image class that we mentioned last time. And all we're doing is we're doing the same thing, but we're sending it to an image class that will send it to SDL and put it on the screen. So I encourage you to look at the previous videos to get that. And then once it fills the QB image class with those RGB values for each pixel, we're coming here and we've got this infinite loop. So it's already generated the image and put it into the SDL window, and we've got this infinite loop while is running as a bool, and we have this, it's waiting for an event. It's calling SDL poll events, which basically tells SDL, hey, do you see any events? And if it sees a 0, there's no events. If it sees anything else than a 0, there is an event. And we set it up for when we hit that close button on the window, that will generate an SDL quit, and it will take the is running Boolean and convert and turn it into false, which means the next time through this infinite loop, it will see this as false, and instead it will go out and clean up the SDL window, destroy the window, and check the CUDA errors and free all the memory, and we're all done. So what we're going to do here is instead of just checking for this quit event, we're going to add some code that checks for a key down event. And that's one of the great things about SDL. You can have events from, like we say, keyboards or mouse or whatever. So we're going to say else, it found an event. If it's not a quit event, if it's an SDL key down event, then we're going to say, okay, well, if the event.key.keysim.sim, basically this allows you to grab the symbol of what key was pressed, and the SDL key code of that is SDLK_V, because we're using the V key for vertical flip. And it's going to sense if we hit the V key, and if we do, it will toggle the status of this image flip Boolean. And we're going to feed this image flip Boolean to our QB image class to say, hey, when you display the image and send it to SDL, flip it first or don't flip it first. So each time we hit the V key, it's going to toggle that, and it's going to do not image flip. So that's why we can keep hitting the V key and flip it up and down, back and forth. So we're just adding this code. We're negating the image flip. And then we are calling the QB image class. We're calling the mImage, which is the instantiation of the QB image class, mImage.display method, which actually displays the image to SDL for in the back buffer. We're saying image.display, and we're feeding it the image flip. So we're going to have to change this display method to recognize this input of the image flip. To when it displays it, it's going to look and say, do I need to flip it or not? And then once we've done that, we're using the SDL render present like we did last time, and it actually takes the renderer class, which is basically the back buffer that has the image, and sending it to SDL window to actually render it, all right? So pretty straightforward. All we're going to have to do is modify this display method to recognize this image flip so that it will go and do what we want. So that's about it in this, this code for the infinite loop. And what we're going to do is also, when we call the image display, when it's actually rendering, we are now going to feed it this image flip boolean. So the initial one, this is the initial render, we're feeding it this image flip, and then after it's initially rendered, we're going through this loop, and that's why each time through the loop, the infinite loop, we can flip it as much as we want. We're going to have to modify the mimage.display method. So otherwise, all of this is about the same. We're not making any changes, except for at the beginning of this int main, we want to add this boolean image flip, and I'm going to start out with it being false. We can start out with it being true, so initially it gives you the correct rotation. But we have to add this bool image flip equals false. Otherwise, we're pretty much all set. Now we have to go into our QB image class and make it recognize this image flip input boolean. All right. So we'll go to the qbimage.h, and you can see all we've done is we've gone down to this void display and added a bool we call flip. All right. So that's the input parameter. Nothing else is going to change in this qbimage.h. qbimage.cpp, we're just going to change that so that it will now recognize that. So here's our void qbimage display. We got the input flip image, and we're not going to do anything here until we get down to this code inside the line of asterisks. And we're going to have an if statement. So if flip image is true, then we're going to run this method. If it's not true, then we're going to run this other version of the method. Now, the method here is an SDL method called renderCopyEx. And if you recall previously, we had this line, which is SDL renderCopy. And you basically feed it the renderer, the texture, and the bounds of the, where you're going to render it to. And that's it. But there is another version called renderCopyEx that allows you to rotate and flip and do other things to your image. So we're going to utilize this renderCopyEx and give it some more parameters to tell it, hey, do we want to flip it? And if so, how? So if the user says, I want to flip the image, the Boolean coming in is true, SDL renderCopyEx, and we use the same parameters, the P renderer, the P texture, the source rectangle, the bounds, and then we're going to, we can tell it in this value here if we want to rotate it. If so, by how many degrees? And this is in degrees. We're not going to want to rotate, we're just going to flip it. This next parameter is the center that we're going to rotate it around. We're going to leave that null because it's going to use the existing window. And here we're going to, if we want to flip it, we're going to use this last parameter. We're going to specify SDL flip vertical, which tells SDL flip it vertically. Else, we're going to do the exact same thing, but we're going to say SDL flip none. So that should be about it. And with those changes, we can now utilize SDL to flip our image. And again, you can make other changes if you want. Now, one other thing we want to add to this code that we didn't have last time, this might be important later on. The way we had it now, everything works fine, but we're going to add these two CUDA header files. One is include CUDA_runtime.h, and the other is include device_launch.parameters.h. So we're going to add those. It might help get rid of some of the errors that we're getting. Now, if you put this into Visual Studio, this code we had, you might see you will get some errors. All right. A lot of this is because of IntelliSense doesn't get along with CUDA very well, and you can get some errors, but actually they're not real errors, and everything will run fine. but you'll get these annoying errors. Adding these might help, but just keep in mind that I think a lot of it is IntelliSense that you can kind of ignore because everything runs fine. And what we got now, I can hit Control F5 and you can see it all works fine. So, and then I can hit my V and I can flip my image and we're all set to go. So I think in the next video, we'll spend some time taking a step back and looking at the code we've got so far, trying to get some more insight into actually what's going on, trying to understand CUDA a little bit better. I know if you look at CUDA, you might get kind of scared because there's a bunch of stuff there that doesn't look familiar. So we'll take a better look at what CUDA's doing and some of what's going on with the ray tracing. In future videos, we'll try to start extending this, maybe add an IM GUI, a GUI, so that we can have user interface on this, and then change some of the scene objects and ultimately load arbitrary OBJ files. So anyway, if you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications. Most of all, please let other people know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.